I spent quite a lot of time at the start of this year working towards automation, kind of the process of equipping the layout with sensors and that kind of thing and communications for it to be able to run trains on its own. And that was a really interesting process. However, once you get to the point where the trains can run on their own, it can sometimes be a little bit boring. And maybe to counteract this a bit, JMRI does have a mode of running an automated train where it does all the route setting for me, and it changes the points. So I run a train to a particular script the same way as an automated train would, but I actually get to do the driving. And that is something that would really quite interest me. The only problem I've really got with it is to make it interesting when I'm driving these automated trains. There would have to be some kind of interaction. If they're just going around in a loop all the time, it's just like I might as well not be running an automated train. So I need to plot a relatively complex route for these trains, and also one that will make them interact with other trains and have to stop and take action to avoid collisions. And the method that JMRI uses to track trains and make sure that they avoid collisions is signal mast logic. And the way signal mast logic works, as this train's about to demonstrate, is a signal mast lives in one block and it protects the next block. So if there is any detected danger in the next block, whether that's a current detector detecting that there is another train on the track, whether it's a turnout turned against the train in the next block, whatever it is, if it detects that there's danger in the next block, it puts the light for the signal for this block to red. And similarly, for the next block along, 2 blocks along, if it detects a danger in a block 2 blocks along, it puts the signal in the current block to caution, which is in JMRI terms yellow. So if I wanted to effectively drive an automated train, drive a train that JMRI knows the path for, it sets all the points for as it goes along and has a designated start and end point, I would have to observe these signals too and act on them, because if I didn't act on them, if I missed a red signal, whatever, and went through it, then there's a good chance that I'm going to drive a train into a collision. The problem I've got with that is, as this is hopefully demonstrating, a lot of these signals, even on the lower deck, are hidden away and I can't see them, so I'd be kind of crawling around on the floor following the train around to work out when I should be driving a train at full speed, when it should be under caution, and when I should be stopping it. And that's really not practical, and as not enjoyable either. And that's what's put me off driving, trying out automated, semi-automated trains until now. And I had wondered for a while whether it would be possible to write something, because JMRI has lots of open interfaces. You can get lots of live updates on the state of turnouts and signals or blocks from a live interface. And it has a good kind of XML configuration file where you can pull all of the configuration for all the transits and the routes and the trains and the dispatches. So I did wonder whether it would be possible to write something that you could tell it, okay, I'm going to drive this train and I want you to track its journey from start to finish, and I want you to tell me which signal mast it's under and what the state of that signal is at any point, so that I know when to go ahead, I know where to run the caution, and I know when to stop. And it seems like it is possible, and I possibly have got close to doing it anyway, and hopefully this will demonstrate it. So these high-pitched beeps, this is a beep to say you've just gone into a new block, you've assumed a new signal mast, and it's green. Here though, it's gone into caution because up here, the APT, this is the clockwise class 40 here, and it's tracking the class 40, and we're now into red because the APT is about to cross its path and there's a turnout turned against it there. So as well as there being an obstruction on the line, there's a turnout turned against it there, so if it was to go ahead it would derail. The APT is just making its way past now, so as these blocks clear, and these turnouts are turned back in favour of the train going in this direction. There we go, we've gone back to green, and the class 40 can head on its way again. Now this class 40 is being driven by the layout by JMRI. It's automated, but the signal thing doesn't care about that. It just tracks the train on its journey around the layout regardless of who or what is driving it. I'll try then to give a brief and hopefully non-technical explanation of how this app works, how it tracks the journey and how it tracks signals. First of all, everything kind of starts with dispatcher. So if I go, because dispatcher is where we start these automated trains, whether the computer's driving them or not. So let's go down, say, open this APT incline laps one. When I've opened it, this has got some key information in it. It's got which transit the train is going to use, and that's the route set in the XML config file. Like every block on the route is set in as part of that transit, which train's going to run it and what its start block is. So if I expand this, and at the minute this one's going to be run automatically, but if I untick that box, that's where I say actually no, I don't want the computer to run this train, I want to drive this train. Over to the app then, and it has a path to the config XML file for JMRI, and it also has a path to where all of these dispatcher saved trains are. So if I go and open those files, I'll see a drop down here, and this corresponds to all those files that are in the dispatcher folder. So I was looking at APT incline laps, wasn't I? So let's click that, and here we'll see some corresponding information, what the train is, what the transit is, well, what the start block is. And from that, because it knows where the XML file is, it's already now gone into that transit, and it's picked up every block. It's picked up information about the route that train is going to take. Now that train might not take the exact route that's in the config file because of alternate routes, so it has to bear that in mind, and that's where live tracking comes in. We have all that config data then, which is incredibly useful, but we do need live updates. We need to know what's happening now on the layout as well as how everything started out. And in order to provide that, amongst all of the web servers that JMRI offers, it does offer up a JSON server, and the JSON server can give us live state information on sensors, turnouts and blocks, maybe a few other things as well, but these are the critical ones for us. If we take turnouts, for example, if I go to the URL /JSON/turnout, I can see a list of all turnouts and what their states currently are. But if I'm interested in a specific turnout, say turnout MT3001, that's its JMRI ID, then I can get just the information for that. And we see it currently has a state of 2. State is its thrown or closed state. The 2 is an enumerable that just represents closed. And so if I go to JMRI and I click on thrown, and then I come over here and refresh this page, I can see that state's gone from a 2 to a 4. So I can see that I can get live updates through this server on what the current state of various objects are. And that goes for blocks as well, and this is especially useful because this helps us track the journey of our train. And the first way it helps us by doing that is if I go into dispatcher and I actually set a train off. So let's set that APT one off, incline laps, and we don't want it to run automatically, but even by doing this it will start allocating for it and getting it ready to run. So let's click on create. And we can see here that a few blocks have been allocated to it, the next few blocks, and that's if I just quickly move this over, we can see that on here as well because they've been set to yellow. So coming back over to the config in here, I'm going to find my blocks. What I can see is I will find, I think, are these blocks? These are not like blocks. Let's click out, back in again. Here we go. I can see that AC pi end, AC yard exit and AC yard bypass pi end have had the value APT put in them. Now these happen to be the 3 blocks that are illustrated yellow on here. So what dispatcher is doing is as it allocates blocks to a train, it's putting the train's name in the value field. So now going back to my my JSON thing here, if I copy the name, say, of AC pi end, I think I can copy the username. Oh, that's the username I need to copy. is it going to let me copy? I don't fancy typing it out. Am I going to be able to get it from there? No. I'll say we're going to have to do this the long way then. So if I go and find on, is this blocks? Yeah, AC pi end. There it is. This is its name, so I can, same as I was doing with turnouts, I can say I'm just interested in this one, and what we'll find if I've got the right one is it has a value here of APT. So because my app, going back to the cab signals app, knows the name of the train because it put that in there when we selected the dispatch, which had the name of the train in, it can look for the blocks that are being allocated to this train as the train goes around. So it can always be working 3 blocks ahead of where the train currently is, assuming that you're allocating sections 3 at a time, and it can start building a live structure of the train's future journey, which may differ from the configuration one because there are several runtime factors, the most important one being alternate routes. So using these blocks and the values that it's picking up live from JMRI, it can determine which particular alternate route a train is taking if there are alternate routes on its transit. So via a combination of config and that live JSON data, we're now tracking where our train currently is, its current block, its next block, and a couple of future allocated blocks as well. So once we have that information, we have enough information to start looking up which signal mast is currently governing it. And I'm not going to pretend this was the most difficult bit. You have to get right into the config, even the config of the XML config of this layout panel itself, and into signal mast logic in order to work out what the next signal mast is. It wasn't easy, but I think I've got it working. Now we've determined that, and we've got our signal mast, and we've got our block that the train is currently in. It's just a case of determining what the state of that signal mast currently is, and to get that we go straight back to the JSON server and we query for, notice the capital M, that caught me out for a while, it is case sensitive. So we go to signal mast, capital M, and then again we know which signal mast we're under now, so we query it, and obviously all of these JSON queries can be are handled in the C# code. The JSON actually looks like this, and that's what the C# code is constantly querying, and then it receives it and reads it. But the browser here just makes it nice and readable for us. And the key thing here is once we get the information back for the signal mast, it tells us what its current state is, which is what then feeds back into the app and determines the green signal image and the nice little beep. And there are different images and different beeps depending on whether this is proceed, caution, or danger. I'm going to try then to drive a train and be governed by the cab signals. So I'm going to drive a train that's simply set to do maybe 7 or 8 laps of this clockwise loop. Once I've got it running and I'm sure everything's all right, I'm going to set an APT off to run round the opposite way. But the thing with the consistor, so the APT is going to be fully automated and I'm not going to be driving that. But the thing about that consistor is it's going to go across this clockwise line. So at various points, the train I'm going to drive is going to have to stop or it's going to crash into the APT. So I need to tell this cab signal software which train I'm driving so it can keep a track of me, or which dispatch I'm driving, which is this one. I'm going to open it, I'm going to start my journey, and this is now sat watching, ready for activity on the line, I guess. And over here I'm going to open the same dispatch in dispatcher, which is that one. Don't want it to run automatically, and I'm going to create it. And that has immediately set a few bits of data here. It can see what signal mast it's on and all that stuff. So now it's just up to me to start driving this class 40. And that's going in reverse. I'll try driving it forwards and see if that improves things. So here we go, let's get it up to some decent speed. And leave it going at that speed. There's nothing to impede it on this lap. So I've just got a green light. And I don't know if it's audible on the recording, but every time the train goes into a new block, there's a green beep. Or in fact, every time the train assumes a new signal mast. And that's just to say that everything's okay. That little high-pitched beep like that one is just saying you're green, you're okay, carry on. And the audio changes depending on which signal colour is on. So I'll let this one get a little bit further round, and then I'll start the APT up to start going the other way, and then to very soon after that cross the path of the 40. I'll leave this one with its default values because this one is going to be running automatically run by the layout. So let's set that off now, and there should be now an APT running around as well. Again, I keep an eye on my little bit of software, but I just keep getting these brief high-pitched beeps and the green light, which means my train's fine, it has no danger ahead of it, no caution, it's chugging along nicely. It's soon going to have a bit of an issue though, because the APT is now on its way around, and very soon the APT is going to cross it onto the incline. There's actually, oops, I've lost it. There's actually a bit more info on this cab signal thing. Where's it gone? There is quite a bit of debug info if I drag it over here a bit. It's tracking down here its current journey log block by block, and that's because the journey could change. Although it's loaded in the original kind of journey manifest from the configuration, there are alternate sections and things like that that could mean that the list of blocks that is in the config is not necessarily the same blocks in the same order that the train's actually going to traverse. So it builds up a live log based on occupation here. So now I can see the APT is coming around here, and it's got these two turnouts blocked, and this better get on with this. So now I'm setting this down to caution speed because it's in caution because it's coming around here, and there we go, we've got a red light as well. So I'm just gonna stop that class 40, and it now has to sit, and I can see up here the APT is crossing onto the incline across this line, and as those blocks that it's been crossing on now become unoccupied, what should happen, there we go, I've gone green again because the points have been set back, so I can get on with my journey. The APT, however, is only going to do one lap as it goes around the incline, and very soon it's going to be coming back down again, so I'm going to have to do the whole thing again. Here already it's got these points, junctions reserved. So again, here we go, I'm under caution already with the class 40, so let's slow us down. And there we go, we're red again, so I'm going to bring it to a nice calm stop. And as I can actually see the train here, I can also see that coming over here, hopefully, this is the red signal that it's behind. So as the APT, I'll kind of hang around here, the APT's speeding up now because it's come past. Once it clears, there, I got the green beep and I saw the green there, so I can set my class 40 off on its way. There's the confirmation there that we've gone green again. and we're happy and on our way again. And I think all that's left now is that both of these consists are pretty close to coming in and parking. I can see there's a turnout here coming into the yard, so the APT this time around has had enough that's coming in, and I don't think the Class 40 will be far behind it. Again, my signals here should guide me to the end of the journey as well and tell me when to stop. Still green at the minute, beeping away happily. It's just going across up the top here, and I'm under caution now, so let's bring the speed down. You can see it's coming in here, and it's got a yard line here occupied, allocated. So what I hope will happen as it comes in, I can see its progress. These lines go red as it occupies them, and as it occupies the one at the end, I should get, there we go, a red, and it's told me that my journey's pretty much finished. I need to sort those out, but if I turn back and have a look here, there's the 40 parked happily back in its spot, and the APT came in at some point as well and parked itself there. I think there are already a few cab signals solutions in JMRI, but I think they're specific to certain types of hardware, and I don't use that hardware. I think what it really needs is, and I wish I knew Java. I've kind of gone, because there were so many unknowns when I started this, I didn't know whether I'd be able to do it or not. I really kind of went for the environment I'm most comfortable in, which is C#, Windows Forms, that kind of thing. And unfortunately, that kind of makes it very non-universal, if you like. I think a high proportion of JMRI users don't use Windows, they use iOS or Linux. There's a page in Dispatcher that kind of gives all the information that you need, almost all the information. I think it tells you what your train is, tells you what section it's currently in, what it's in next, and it also says what signal mast it's under. And if, as kind of a bare minimum, and I wish I knew Java or Python, whatever Dispatcher's written in, I wish I could just dive in there and add it myself. But what would be really helpful and useful would be if those lines of page were maybe available as a JSON payload that we could query, send it the name of the train, the name of the dispatch, and we get back all that information that you can see on the Dispatcher page, or better still, maybe a web page where you can interact and they put the icons on themselves, so you see a list of dispatches that are currently running. You click on the one that you're running and you get a little page that's got a traffic light on it, that a signal on it that refreshes. But I'm sure there's a lot of work in that, and like I said, I wish I could just roll my sleeves up and dive in, but I just don't know Java well enough to do that. I think it's important, with all of this time that I'm putting into the technology, sorry about the roadworks, that I make the most of it that I can, really. And stuff like the cab signals, different ways to play with trains, I guess, different ways to interact, will keep the interest, I think. So that there's always going to be the days when I just want to come up, just drive trains, and not have any automation at all. Although to an extent there'll always be some automation, like the routes that set the points out of the yard over there. I'll always use that, and it is a level of automation. It does, it groups a number of tasks together and performs them for me, which kind of is automation, really. And although the usage of it is a little bit limited at the minute, in that I've only really got those 2 loops and the incline, and there's a limit to the amount of interaction you can have between trains on there, I am really starting to think seriously about the upper deck now. I've kind of got all this major junction work done, and it's just a case of starting to lay track around. So that's really got me thinking about the station, and I'm halfway through a video actually of kind of describing how that's going to work. But with the different potentially different uses of the layout and modes of the layout, once that's all there, I think the semi-automation thing can work quite well, because full automation's great and it's fun to get there and it's interesting, but once you're there, it's just trains going round and you're not really interacting with them. And I've always found it very difficult with the full automation to just pick up a throttle and drive a train, because the automated trains don't really know that that's happening. The JMRI doesn't know where you're taking that train, so it can't allocate sections for you, and you can't see signals, so you're very much kind of dodging what's there, and I don't think it's the right way to interact with automated trains. Whereas the semi-automation, where the layout knows that you're going to drive a train, it knows where you're going, and it's setting the route for you, it's allocating blocks ahead of you, so other trains, automated trains that are running at the same time, are aware of you. That's a much better way to interact with automation. But it does need that element of being able to see every signal. Also, JMRI has this kind of schedule approach to running automated trains, where it simulates a day and has a schedule, and certain trains depart from certain places at certain times with certain transits, routes, and have an end point. And I think an interesting way to approach that would be to have maybe the majority of your trains are run automatically and fully automated, but certain selected ones through that schedule, through that simulated day, have to be run by a human. When I'm up here in the loft and that schedule's running, it's kind of up to me to make sure that I grab a throttle and run the right train at the right time, because if it doesn't, I'm probably going to cause mayhem. So that kind of thing, the cab signals assist me with that, because whenever I'm running one of these semi-automated trains, I know when I need to stop, and I know how to avoid collisions. Of course, that's scalable up to not just one guy in his loft. That can scale up to any kind of more communal layout, where maybe the volume of trains increases, but also the number of people who can grab a throttle and drive the right train at the right time increases too.